The beginning of the universe has always been a matter of controversy. The Big Bang Theory makes us believe that the universe began as an initial explosion, and then everything expanded. However, there are many gaps in this theory and a lot of misinformation. Did the Big Bang really exist? What would you think if I told you that we have been wrong all this time? Forget everything you have been told until now. Today I assure you that you will understand the origin of the universe, and we will also reveal the nature of the initial cosmic entity, something that has never been done. Thanks to various tests at CERN and more recent mathematical theories, we can deduce what is hidden in that initial moment. Never before will you be so close to your cosmic origins. Maybe when you finish watching the video, your concept of reality will change forever. The cosmos is immense. You will see that there are millions of stars. These bright points correspond to our galaxy, and we see them moving at the same time, because the Earth rotates on its axis. However, beyond them, with a powerful telescope you would see galaxies. Logic tells us that we live in a static universe. This point of view even fooled Einstein, who added the cosmological constant to his equations of relativity. At the beginning of the 20th century, we discovered that relativity described a dynamic and evolving cosmos, in expansion or contraction, but in no case static. Einstein's relativity proposed that we were immersed in a network called dynamic spacetime, where mass and speeds deformed this fabric. But logic contradicted all this, so Einstein added the cosmological constant, whose effect was to compensate for the action of the mass of the entire universe so that it would be static. Just as we have discovered that the universe is not static and expands simply because the cosmos is very large and there are millions of galaxies with which we can compare their speeds and make calculations thanks to relativity. This, which seems easy now, was discovered in part by Vesto Slipher, where he found that the light from the galaxies presents a red shift, the Doppler effect of light. The Doppler effect is the change in frequency produced by the relative movement of the source with respect to an observer. Following this principle, we can see if an object tends towards red when it moves away, and if it tends towards blue it would approach us. It is similar with sound. If you hear the audio of a horn, when it approaches it is higher pitched and lower pitched when it moves away. Also, the Russian cosmologist Alexander Friedmann discovered more surprising things. Thanks to his equations added to Einstein's field of spacetime, he theoretically deduced that spacetime itself was expanding. In other words, it meant that the universe was expanding. It seemed incredible, but Edwin Hubble confirmed it by seeing galaxies outside the Milky Way moving away from us in all directions. He did this by measuring the red shift in the spectrum of the light emitted by these galaxies. Galaxies were not expanding equally. The farther they were from us, the greater the red shift. This observation suggested that the galaxies were moving away from each other, which was consistent with the idea of cosmic expansion. In other words, Alexander Friedmann was right and Einstein's field equations were not wrong. Although the cosmological constant was, this has a lot to do with the origin of the universe. Knowing cosmic evolution, it is easy to rewind the film back to the beginning. If everything is expanding, it is clear that in the past everything was much more united, both the galaxies and the spacetime that contains them. There had to be an initial singularity, a primordial atom or cosmic egg, as the Belgian priest Georges Lemaitre defined it. Initial singularity. But how is it possible that everything was in an initial singularity? A mass concentrated in a very small volume can give rise to a singularity due to the predictions of Einstein's theory of general relativity. In this theory, gravity is not considered simply as a force between masses, but as the curvature of spacetime caused by the presence of mass and energy. We have seen it in black holes. As an example, if the Earth were to compact to a volume smaller than a marble, it would become a black hole. We can use this example with the mass of the universe. So imagine all the spacetime folded and the matter of the universe concentrated in a single point. It would form an infinite spacetime singularity. In this way, the temperature also becomes infinite due to the extreme concentration of mass and energy in a single point. And when the temperature is so high, any particle moves so fast that it cannot form atoms of matter. That is why we imagine that initial singularity, a soup of energy concentrated in a quantum volume, then that must have expanded and exploded. It seems ridiculous, and Fred Hoyle thought so, as he referred to the initial singularity in a mocking tone as the Big Bang. At one point everything was united and then there was a bang, a term that was so successful that it is still used today, but here we have a problem. The universe is considered everything that exists. Now imagine the initial singularity. If there is an explosion, the matter has to expand out of that singularity, and that is impossible. This is wrong and needs to be made clear. There was no Big Bang. Amazing but true, there really was no Big Bang. Many textbooks and documentaries still refer to the initial Big Bang. There are even books that calculate the speed at which those particles were expelled. The singularity was the entire universe and means that nothing exploded. It simply began to expand at some point from an extremely dense and hot state, at more than 2 trillion degrees Celsius, and as it expanded, it cooled, and the particles were able to form the atoms of matter. The Big Bang theory should be called the theory of total expansion, if we had been more correct. So it is normal that it confuses many people. However, even though the term Big Bang may not be the most accurate description of the event, it has been widely adopted due to its ability to convey the idea of an explosive and dramatic beginning of the universe to a general public. It helps to visualize a moment of great change and expansion. The Big Bang does not explain the beginning of the universe. There is more. The so-called Big Bang theory does not explain how the universe was created, but rather describes how the universe has evolved from an extremely dense and hot state in the past to its current state. The Big Bang theory focuses on the expansion of the universe starting from an initial moment, but it does not provide a complete explanation about what caused that initial event. So no, we cannot explain the beginning, and that is because the Big Bang's singularity represents an extreme situation where the density and temperature of the universe are infinite. Under these conditions, physical and mathematical equations can give results that are difficult to interpret, or even tend towards infinity, indicating that our current theories may not be valid at those extremes. Also, we do not know how time behaves under those extreme conditions. So we can only explain the initial moment where the universe made some sense to us and our equations worked, and that corresponds to the first temporal pixel associated with the age of the universe, said in scientific terms, the Planck time. Planck time is a fundamental quantity in theoretical physics that arises from the theory of relativity and quantum mechanics. It was first proposed by German physicist Max Planck and represents the smallest time scale on which something meaningful can occur. On such scales we can begin to explain any event that occurs in nature. Planck era. The Planck era is the instant 0 to 10⁻43 seconds, approximately 1 Planck time, meaning that we can only explain the universe on a Planck time scale, in which the 4 fundamental forces were unified into one. Of course, we can imagine that before that there was a very dense initial singularity and fluctuations thanks to quantum theories. But it cannot be explained why there was a singularity, and what caused that expansion creating space-time. Why does the Big Bang work? Why does the universe expand in all directions, and only the closest galaxies are joined thanks to gravity, thanks to the rate of expansion and observation of supernovae? We have determined that the universal film began more than 13,700 million years ago. Matter is mostly made up of hydrogen and helium, which accumulate 98% of the mass of the universe, and this is consistent with the Big Bang theory, and this is because the initially dense state of the universe until its growth. Normally, lighter elements are formed at the beginning and the rest are synthesized inside stars or in supernova explosions. These proportions agree with those predicted in simulations. Any other different beginning, for example an eternal universe, would have given rise to many more combinations of elements than those currently observed. The cosmic microwave background is another clue that tells us that 379,000 years after the Big Bang, the universe was so homogeneous that given the enormous scales it would only have been possible if it had been born from a tremendously small region, and those temperature variations between blue and red points were once quantum fluctuations. Imagine a sheet of paper, now folded and compacted as much as you can. That is the initial universe in a compact state, and now if you unfold it you will see wrinkles. Those are the fluctuations in its high-density state. Following this analogy, if we study the universe as a whole, We see that it behaves the same everywhere, and there are quantities of matter distributed evenly on a large scale. There is no privileged place, and that is why there is no center. If there were a center, we would see all the galaxies concentrated in one point, and then fewer galaxies as we move towards its limits, just like a galaxy. But we always find galaxies and as the galactics with the same physical laws. That can only mean one thing, and that is that the universe arose as a whole from a tiny point. This is the basis of the cosmology that we call standard today, but we also have many problems with this theory. The universe is accelerating, and that can only be explained with a mysterious form of energy called dark energy. If the Big Bang theory were correct, we shouldn't exist. The universe likes Zen mode, the balance between yin and yang, everything being preserved even if it is transformed in one way or another. According to current theories, during the early stages of the Big Bang, we would expect equal amounts of matter and antimatter to be created, since the extreme conditions of the early universe would allow the production of both in equivalent quantities. At SUN we have verified that every particle has its antiparticle. When matter and antimatter come into contact, they annihilate each other, becoming energy. If an equal amount of matter and antimatter had been created during the Big Bang, we would expect them to annihilate completely, leaving a universe composed only of radiation. However, we observe that the observable universe is composed mainly of matter and contains very little antimatter. On the other hand, James Webb is finding very evolved galaxies at the beginning of the universe. It is as if everything had formed much faster or had more time to form. This does not invalidate the Big Bang theory, although it does raise many questions. The nature of singularity. In the universe, everything tends towards disorder, and that also means that the initial singularity had a low entropy. That is, it had an order, and at the same time it was very simple. Everything in the universe comes from previous simpler states. On our planet, life forms became more complex in an evolution of millions of years. It is evident then that the universe must come from something simpler, more ordered and moldable, capable of adopting many forms. We are witnessing a dimensionless micro-universe, of infinite density and energy with zero time. Everything we are, what we were and will be, was concentrated there, in the form of encoded information of primordial energy. And this is where things get really strange. Some call it a creator, others a quantum machine, even a living being. Current relativistic and quantum theories do not contemplate any of those states. It is something completely different. Hypothetically speaking, it has no time. However, quantum affects the arrow of time can take any direction, and all events can happen in imaginary time. Imaginary time is not conventional time, but rather an additional dimension to explain all phenomena in this quantum state. This is the so-called cosmic egg, and within it there are four fundamental forces known and unified as one. The electromagnetic strong and weak interaction, and gravity maintain the order of the fundamental forces as if it were a protective layer that holds everything together. The temperature is billions of degrees Celsius. In this quantum state there are always random fluctuations, and the cosmic egg broke, and that is when gravity separated from the three forces and the primordial energy takes different evolutionary paths. At that moment is when our four-dimensional space-time was created. However, the density of the universe could be enough for it to collapse on itself again. One of the quantum fields called inflation overcame gravity, causing an expansion, and the micro-universe went from the size less than an atom to about 10 centimeters in less than a second. With the cooling of the universe, elementary particles were able to combine, forming atoms and matter. The cosmos continued to expand at a slower pace and continues to cool. We are the result of 13.8 billion years of evolution, from a dynamic and unified energy entity. This moment is one of the great mysteries of cosmology, and many scientists continue working to understand it. Some will say, what came first, the chicken or the egg? Obviously the egg. We were not exactly born from a cosmic egg, but it is a good analogy to understand it. There was not really a Big Bang, but a division of forces and quantum fields that each evolved differently, causing an expansion. But in the end, how do you know? The universe really began when you opened your eyes and were born. You became aware of the world, acquired knowledge, and were told about the past. However, you were not there to prove it. This leads us to a terrifying hypothesis, and that is that it could be the dream of an already extinct universe in a plasma state. A floating brain is much more plausible than a long process of cosmic evolution to create a human being. If many floating brains originated in a non-living universe, we could be experiencing reality as if it were real. But whether what you are witnessing is real or not, enjoy the ride. As Carl Sagan said, we are the means for the cosmos to know itself. So let's keep experimenting together, until there are no more questions left to answer.
Hush.